Hey everybody, how's everybody doing today? Hope you're having a good day. I just want to give you kind of a general summary of quadratic functions. So if you remember what we did in class on Friday, we talked about the different properties of parabolas, and then we kind of left it off with the quadratic functions in standard form. And so I want to focus on that piece of it too and give you just a nice summary of all the different things, axis of symmetry, vertex, y-intercept, minimum, maximum, all the different things that you can find from your standard form of a quadratic function, which is different than the vertex form, so another new form. So just as a reminder, the standard form of a quadratic function is f of x equals a times x squared plus bx plus c, and a has to be greater than 0 or it has to be less than 0. So basically what happens is this one it opens up, this one it opens down. So similar to a vertex form. And so what are all these different properties? Well, we already talked about the opening direction, and so we know that if a is positive, we're going to have a parabola that opens up, and if a is negative, we're going to have a parabola that opens down. Okay. To find the axis of symmetry, we talked about looking at the graph and finding the axis of symmetry. You can actually do it without graphing. To find the axis of symmetry, remember it's going to be a vertical line, so it has a x equals. And what we need to do is we need to take this formula right here, minus b divided by 2 times a. And that's true for both of them. X equals minus b over 2 times a. Now, where do a and b come from? They come from the standard form of the function right here. There's your a, there's your b. A is always attached to the x squared, b is always attached to the x term. Okay? To find the vertex, okay, which is an important point, it's the lowest point if it opens up, it's the highest point if it opens down. To find the vertex, if I give you this function right here, what we need to do, we know it's going to be a coordinate, and the x-coordinate of the vertex is going to be your axis of symmetry, which is like we discussed earlier. Now the y-coordinate is going to be, let me write this down, f of the axis. Basically what you have to do is you have to take whatever you get here, which is what you get here, and you need to plug that into your original function to get the y-coordinate of the vertex. And that's true for both of these. Oops, AXIS. So you take whatever number you get up here and you plug it in there. Okay? All right, the next point that we're going to be able to find in the standard form is the y-intercept. And the y-intercept is real simple. To figure out where the y-intercept, it's the c value. Okay, so the y-intercept equals c. Okay, this c value right here. And if we want to write it in coordinate form, it's 0, comma c. And once again, that's true for both of these. All right? The minimum or maximum. Remember, the minimum is the lowest point. The maximum is the highest point. Well, what else do we know are the highest and lowest points? The vertex. Okay? So the minimum, so here, if the a is greater than 0, we know it opens up, so we know we're going to have a minimum. And the minimum value is going to be the y-coordinate of the vertex. Okay? Because think about that. That's the lowest point. When we talk about high and low, we're talking about y-coordinates. Similarly, if we have if a is less than 0, it's going to open down, so we're going to have a maximum point. And once again, what's that going to be? It's going to be the y-coordinate of the vertex. Okay. Domain and range. We've talked about domain and range off and on throughout the year. Remember, domain is your x-coordinates that work, and range is your y-coordinates that work. So, in terms of quadratic functions, the domain is always going to be all real numbers. And remember, we can start using that symbol right there. Okay? And that's going to be true whether it opens up or whether it opens down. Okay, so that's our domain both time. Now the range is very interesting. If you think about the range, we have a minimum value, which is the y-coordinate of our vertex. And think about the shape of a parabola. That's our lowest value, is everything above it. So our range is always going to be y is greater than equal to the minimum. Okay? And if you have it where it opens down, you're going to have a maximum. And it's going to be y is less than or equal to the maximum. All right, so what do the graphs look like now? Well, we know that the graph, if it opens up, is kind of this nice parabola shape. And we know right down here, this is our vertex, which is also our minimum. We know that our axis of symmetry is going to divide it in half. So I'm just going to write axis down there, kind of abbreviate. Same thing if it opens downward. Okay, so if I open this downward, it's going to look like that. Okay, this point right here will give us our maximum, which is also the vertex. Our axis of symmetry kind of goes right through the middle. So that's our axis. And I think we all know what the y-intercepts are and those types of things. Now, last thing I want to talk to you about is what's called a decreasing function and an increasing function. Basically, decreasing means that it's going downward. The y values are going downward as the x values are going upward. Increasing means they're both going up at the same time. The easiest way to look to see if something's decreasing or increasing is look at the graph. So see how this graph is going down as I move to left and right? It's decreasing until I get to the minimum or until I get to the axis of symmetry. Then it starts to increase. Okay? So this piece right here, right there, that is decreasing. So I'll just write decrease for short. And you can see right here, it's increasing. Okay? Because it's going upward. Looking here, if you see we're going from left to right, this is going upward. So here, I have increasing. And then I get to the axis of symmetry or my maximum, and it's decreasing. And I'm just going to abbreviate that because I ran out of room there. Okay? So let's talk about what those things look like as far as a description. So notice it's decreasing until I get to my axis of symmetry. If you remember from right here, what's my equation for axis of symmetry? It's right there. So what we want to say, this is to the left. It's decreasing on the left-hand side of my axis of symmetry. So this is decreasing to the left. Of x equals minus b over 2a. And you can see to the right-hand side of my minimum or of my axis of symmetry, it is increasing to the right of x equals minus b over 2a. And you can see it's the reverse of this. So if it opens down. So if it opens down, you can see to the right, the maximum is decreasing, and on the left-hand side of the of the axis, it's going to be increasing. So it's increasing to the right of x equals minus b over 2a, and it is increasing to the left of x equals minus b over 2a. Okay? So this one, if it opens up, you can see it's going down on the left-hand side, decreasing on the left-hand side. On the right-hand side, it's increasing, so on the right-hand side, and then vice versa. Okay? All right. So last thing, let's tie these things all in together. Okay? Because you can see that a lot of the pieces are related. So let's start with our axis of symmetry. You can see the axis of symmetry. The actual formula to find it is minus b over 2a. So let me circle that in a beautiful orange. Okay? Once again, where does this minus b and the 2a come from? It comes from right there and right there. Okay? Or right there and right there. Okay? This is the first thing we should always find, because once we've found that, we're going to use this number, and it's the x-coordinate of our axis of symmetry. So I'm going to highlight those the same color so that I know that this thing is related to this thing, and this thing is related to this thing. Where does all this stuff come from? Up there. Okay? Also notice, to get the y-coordinate, I have to take whatever number I get here, which is the number I get here, and plug it back into my original function. So all of those things are related. Okay, so I want to highlight those the same color so I know where things are coming from. All right, what's next? So we find the axis of symmetry that comes from those values. The next thing I find is my y-coordinate on my vertex. So I'm going to highlight the y-coordinate on my vertex in green. Now, the cool thing about that is that whatever this y-coordinate is, that's also my minimum and my maximum. So I'm going to circle those in green so that I know that my minimum and maximum value are related to the y-coordinate on my vertex. Okay? Also, if you look down here, the range is related to your minimum and maximum. So let's highlight those in green also, so that I know they're related. Just like that. Okay? So there, so I've got those things. What else do I know? Okay, if I go back up and do the y-intercept, notice the y-intercept is the c value. So let me circle those in blue or highlight them in a different color. And where do I get that c value? It's right there. So I just got to look at that. Whoops, where is it? It's right there. So I just got to look at that, and you can automatically, boom, tell me what the y-intercept is, whatever that number is right there. Okay? All right, now let's go down to the graph. Let's talk about increasing and decreasing. I know, let's see, what colors haven't I used yet? Ooh, purple. I know that it's decreasing. If it opens up, it's decreasing on the left-hand side. So I know that this here is this part right here. And I know here is that part right there. So it's decreasing on the right-hand side. And finally, one more color. Woo, pretty pictures. To the right, to the left, to the left, to the right, to the right. Great song. All right. To the right, it's increasing, and over here on the left side of my axis of symmetry, it's increasing. Remember, increasing, decreasing. We always go from left to right. What's happening? So down here, whew, good thing there's no more. This is my last color I haven't used. So down here, highlighted them, and what is that? That's this piece right here. And that's that piece right there. Okay? All right, so that's a lot. All right, that's a lot, I know. But if you have this chart, and we use this chart as a reference, and yes, you'll be able to use it as a reference throughout the unit and probably for the quiz too, because it's important that you just know how to do the calculations. So if we have this, you'll be able to find lots of pieces of information about a quadratic function, and more importantly, the graph of the quadratic function, because that's what we're dealing with. You'll be able to find the axis of symmetry. You'll be able to find the y-intercept. You'll be able to find the min and max, minimum and maximum values, domain and range, and where it's increasing and decreasing. Okay? We'll stop with there. Hope you have a good weekend, and